These objects in the and they left because
Can you hear me? Good. Okay. So, hello everyone. Thanks for joining me today. Some info about me. My name is Luca. I'm an Italian Android engineer. I'm currently based in London, and I'm working for Babylon Health. Today I'm going to talk to you about MVI and Jetpack Compose. I have some questions for you. How many of you have ever heard about MVI? Okay, perfect. How many of you use it in production? Wow, one. Perfect. How many of you have heard about Jetpack Compose? Some more, great. How many of you have ever tried it out? Perfect. Any Flutter or React developer in the room? No one. That's great. Okay, so let's start. MVI, well, it's also known as Redux in the web world. It's an architectural pattern which allows us to consider the application as an unidirectional data flow which has no start or end and can be considered as a loop. For now, let's assume that the loop has a beginning point, which is the user interacting with our application. The interaction generates some intents, and those intents manipulates the model of our application. The model being updated, it's then being reflected to the view, which is rendered back to the user completing the loop. So the core principle in MVI, it's unidirectional. So the data flows only in one direction, and we don't have data going back and through different components of the pattern. It's immutable, so the states never change. Every time a new instance of the state is being produced, it's reactive, so it takes in consideration user interaction. And in fact, user interaction are part of the pattern, and it's functional. So everything in the MVI pattern is considered as a function. As everything is considered as a function, the MVI can also be represented like this. And every function accepts as input the result of another function. So we assume that the flow starts from the user interacting with the application and generating actions or indents, which are then consumed by the business logic of our application. But we know that it's not always the case. We could also want to perform some business logic based on system events like Lifecycles in Android. And this is the reason why we ended in our implementation of MVI, we ended up accepting something instead of UI interaction. So we start with an initial state, which accept action that are consumed by transformers and pass through reducers. The reducer emits new states, which are then rendered back to the UI. We ended up accepting something because we wanted our architecture to be usable without any UI as a headless system. So from the previous graph, we can clearly see some core components in the pattern, which are action generated from the user or from the system, transformers, which apply the business logic of our application, reducers, which generates new states, and the states themselves, which represent the model of our application. But how do we know which transformation or reducers is needed to be applied to each action? We created a component which we called middleware. It works as a glue, so it binds action to transformers and transformation to reducers, or action to reducer directly. This is because in our implementation, transformers are optional. We don't always want to apply business logic to an action. A basic example will be a toggle switch. The user just click on the toggle, but there's no business logic needed. We just need to update the state of our application. So in our code base, we end up with something like this in the middleware. The perform action just assert what's going on here, and as we can see, there's a rating selected action, which is just being reduced. There's no business logic applied to this action, and it will most likely update the UI coloring some status on the screen. Another example would be like this. We can also map more than one action to the same business logic, to the same transformers, and to the same reducer. And as I said before, we can also accept lifecycle events, for example, the activity being created. So in this scenario, the data of the user is being loaded as soon as he reaches the screen. So how MVI help us? Well, it helps us with decoupling. We have no classes which handle more than one single purpose. This actually comes alongside with every other well-structured pattern, but it also helps us with testing. We are able to unit test almost every component of our architecture in isolation. We can do that without using the Android test folder. In fact, those tests are inside the test folder, as you can see, and so we are allowed to run those tests without any emulator, and those tests are completely independent from the Android framework. We are relying on the Android framework just for testing the UI components, the view components of our architecture. Those tests represent the most complex tests in our code base, and they represent a walkthrough, so the entire journey that the user would perform in our application. We consider them to be end-to-end tests, as they're testing everything inside the app. Even those components we are already unit testing in isolation, reducer and transformers. So the view components of our application, it's something like this. We end up having activities or fragments which renders something on the screen. Or maybe we have a special class, which is a renderer class, which in the end renders something on the screen. So this is an example of a render function. We receive a state, and then we show or hide views based on some condition inside the state. This show function is nothing more than an extension function of view, no magic here. We also use this approach referencing the menu button and enabling or disabling them, and also to show dialog. This code example are full of references to view and XML elements, and that might lead some problems. So, just an announcement before we start looking into Jetpack Compose. At Babylon, we love open source, and we're going to release our implementation of MVI really soon. We already went through a lot of problems which MVI comes with in the Android, and we'd like to help other developers having those problems solved. So, Jetpack Compose. Jetpack Compose has been announced this year at Google I/O. There was a session, Declarative UI Patterns with Android Jetpack. And they stated that it is in an early exploration, pre-alpha stage. The API surfaces are not yet finalized, and it should not be used in production. But what's Jetpack Compose? Jetpack Compose is a UI toolkit which allows us to use a declarative UI pattern. It's concise and idiomatic thanks to the Kotlin language. There's a podcast in which they state that doing such a library in Java would almost not be possible. It's based on components. being them stateless or stateful. And those components are meant to be reusable. It's also compatible. So they promise compatibility with existing view. So they introduce an annotation for backward compatibility. This annotation was meant to be used to generate a view class, a standard view like any others we already have, which you then could use inside an XML file, or also in code by getting a reference from an XML file, or even initializing it by your own. But this annotation is not present anymore. They got rid of it. They're working on something else, I guess. But I guess they warned us by saying pre-alpha. So Jetpack Compose should also be unbundled from the system. This means that the version of the UI is not bound to the version of the system anymore. And this will be easier for us to avoid issues between different API levels. So how can we try Jetpack Compose? It's kind of hard to do so, actually. There's no radial dependency or plugin which you can add to your application that will allow you to try Jetpack Compose. So in fact, you have to set up repo and download the Android X master codebase. They also joke about it by suggesting you to grab a coffee because you're going to download 6 gig of data. That's a lot. And on top of that, you're not able to use your current installation of Android Studio. The source code comes with a bundled Android Studio version, which incorporates a plugin that enables Jetpack Compose. Once you're done all those things, then you can start working on Jetpack Compose. This is a last-minute update. They're preparing an artifact in order to allow developers to play around with Jetpack Compose outside of the Android X repository. This commit has been merged around a week ago. So how do we use Jetpack Compose? Well, there's a new function, which is set content. You need to call it in the same place where we're used to call set content view. This set content function is like the launch from coroutines. It's an entry point for composable function. This function is actually an extension function on the activity class, which accepts a composable function as an input. What it does, it's really, really simple. It retrieves the content inside the decoder view of the activity, and then it runs the composable function that it received, making it the root view of the activity. But what are those composable functions? Well, composable is actually an annotation which you need to use on function that has no return type. This annotation transforms this function into a component. This is one of the smallest examples for a composable function. It's stateless. It receives an input parameter and it just prints hello and your name. If you go deep enough in the code, you see that the text composable function actually draws on canvas. And that's what every component composable function actually does. In fact, if you try to use the layout inspector on an activity which uses composable function, you're gonna see just one view. And there might be a problem. You're not able to look into every single view it's displaying on the screen. You can see the out paddings, margin, or inspecting any other element of the view. We asked if there's something like debug pane signs enable. That is a flutters flag, which you can pass to the drawing function, and will draw paddings and bounds of the views. There's nothing like it. yet. I guess that they're working on it. I hope so. So I say that the previous example was a stateless component. So how can we add some state to a composable function? There's more than one way to do it. One of the ways is to use the state function. The state function returns a memo, which is an effect that positionally memoizes the result of the computation. This computation is built initializing a state class. The state class is an annotated class with model that it's meant to wrap around a single value. It is used, as we've seen, in the state and state4 effects. The unary class just return the internal value of the state. So a model annotated class should represent your application's data model. The instance of that class becomes observable. Actually, the observer are done on the properties of that class, on the setter function of that properties. That means that if every setter function called on those properties retrigger a compose of a composable function which handle those part of the view. Here is a small example of a model annotated class. Keep in mind that as the observation is done on the setter of the variables, whenever this class is rendered to the screen to a composable function, it will update and recompose the screen whenever the variable is changed, but the part that references the description will never be recomposed. Be aware that you can't do something like this for now. You get a compilation error if you try to do so, but we are able to use inheritance with interfaces, but not with classes. So this was the state of Jetpack Compose the day after they released it. There was nothing like a scrolling container. That means that if your content was higher than the screen, the user wouldn't be able to see it. As for now, there is a vertical scroller. The amount of work done in the 2 months since they released it, it's really, really huge. They're working highly on Jetpack Compose. So keep in mind that the vertical scroller component, though, it's not meant to be used with huge amount of data. That's because it draws on the canvas everything you pass inside of it when you call that function. So there's not a recycle view-like component for now, but they should work on something like this. Hopefully soon enough, and hopefully before they're releasing an artifact. So let's go through some components. Seekparse. Keep in mind that the code that I'm going to show you, it's deep into the composable function. It's just to show you once again that it has some state in it, but in the end it draws on canvas, and it ends up drawing two rect, one for the entire bar, one for the progress bar, and the circle. This code is wrapped inside a gesture detector, which handle the user interaction with the screen and update the state, which will then recompose this function in order to update the screen. They made a lot of work with layout as well. They call them columns and rows, and they provided the most basic feature for them. So rows and columns will take the entire screen on their main axis and will wrap on children on the cross axis. So rows will take the entire width, wrapping on height, and vice versa for column. By default, rows keeps aligned everything at the start and on the main size and on the center for the cross axis. We can tweak them by changing some parameters on the call for the function for the row composable function. And this will change how the children of that row are drawn on the canvas. The same things applies to column. All the columns you can see on the screen here are wrapped into a row. And again, by changing some parameters, you can move the children of that column. Repos. Repos has a huge amount of code inside of it. I'm going to show you just the core things. Well, so repo rect. Why? It's not drawing a rect, right? Well, so what does it? It saves a state which represents the button status. It initializes an onPress function which updates some part of the status as well as the button status. It then defines also also a non-release function which again will update the button status. It then wraps everything with a press gesture decorator and a transition, providing the two functions which are so on press and on release, and a transition function providing a state. This state will recompose the drawing on the canvas whenever it's updated. But in the end, what's going on? It's just drawing a circle, providing an offset, a radius, and the paint to draw it into. Now, dialogues. Dialogues are quite complex component. This is how you start another dialogue. So there's a close request, a bunch of composable functions which represent the title, text, confirm and dismiss button, and then enum to choose how you display the two buttons. What it does, it's saving a wrapper inside of it with a context. Then the onActive is a Lifecycle callback, which is called after the first composition is applied. So here it's showing the dialog and it set up an onDispose callback, which instead schedules the work to be done when the effect leaves the composition. The onCommit lifecycle is called every time the composition commits. So every time the screen needs to be rendered. And as we can see here, it's just providing the children, which is the sum of all the composable functions we saw in the first function, and it's setting the content on the dialog. So, something about testing. A big concern around the community is how we're gonna test those composable functions. For now, all the tests are run with JUnit 4, and since the composable function has no return type, you need something else to make some test. So they're using a rule, compose rule, and here, for example, they're testing the top up bar component, and as we can see, they're using this set material content and collect size, providing the top up bar composable function. This function returns an instance of sizes, which then allows us to assert something on it. So this was a brief interview for Jetpack Compose. Now, when you release something like Jetpack Compose, which has a huge impact on how we develop things, they always start by showing some small code example. And I always wonder, how could we merge something like this in our production application? Because we have patterns which we need to apply. So, in my opinion, for Jetpack Compose and MVI, as we're using MVI, it's that we can end up having two approaches. An objective-oriented approach or a more fancy functional approach. Using an objective-oriented approach, we can incorporate in the view state itself a function which will then render to the screen the state itself. So for every subclass, so every actual implementation of our view state, we're going to override this function and draw, using composable components, draw on the screen whatever is needed. So I say that we start using Jetpack Compose in the onCreate method of the onActivity. So as we've seen inside we initialize our business model components of our architecture. And inside the content function, we render the state that our business logic emits, all the states. The render function accepts an observable on our view state. We set up a state using this observe function, providing an initial view state and the observable. And then as we end up having a view state, we can just call build UI function. And that's all the code that will be inside our activities. The observe function we've seen returns an effect of. The effect of is a class that solves a block of executable code that is meant to be executed positionally in the context of a composition. The effects are equivalent to composable function, which are able to return a value. So we set up an initial state as a result inside the onActive lifecycle. Again, onActive lifecycle, it's called once when the first composition is applied, and it's never called again. So we subscribe to our observable, updating the value inside our result. Inside the onDispose, we clear the reference to the observable, and then we return the wrapped value of our state, which is a view state that allows us to have just 3 lines of code in our activities. Okay, so with the functional approach, as we've seen, again, we're going to start inside the onCreate of our activity. With this approach, we can teach the view model initially. It's not needed anymore. And the setContent function will look something like this. So it's a function which accepts the processed intent, which accepts the intent. The inner function is where some magic happens. So this function subscribes to the intents, which are the user actions, user interaction with our application, and returns some model state. So the model state returns an effect, which wrap a view state. Again, we set up an initial state. We have some lifecycle callbacks here. Inside the onDispose, we dispose the observable, and then we return the wrapped value of our result. Inside the onActive, we're applying the business logic to our intent observer. We subscribe to that observer, and we update our view state every time a new state is emitted. So that's all the code that we're going to need inside our activities. This post-list screen, it's nothing more than a composable function, which set a state. This composable function is composed every time that state is being updated. So we're going to have all the possible state here, which we can then decouple in several different components. So if we focus on this function here, getting rid of the noise around it, we end up having a function of the intents, which, if we go back to what I showed you at the beginning of the talk, so what's the representation of the view model, if we go back and change the color, it's almost the same. So we ended up having a pure functional approach with the view as well, being it a function of the business logic applied to our intents. So hopefully we're gonna reach this state. And that was all for me. Those are some references I really highly suggest you to read about MVI and Jetpack Compose. I'm gonna update the slides and tweet about them. I'd like to thank you for joining me. If you have any questions. No questions. Great. Thanks again.